Here we're continuing with 7.3. We're going to start talking about Introduction to Combinations. Our objective today, scholars, is that students will be able to find probability using combination. So we talked about permutation where it's without replacement. So here, combination now, a permutation occurs when we arrange a subset of elements in a particular order. On the other hand, many times we're just interested in determining how many subsets of a particular size that we can make from an overall set. This is what's known as a combination. The first exercise would introduce the idea and how we can count the combination by first considering the permutation. So they're kind of interrelated, they're mixed, they go off of each other. So the first one says, consider a set created by the letters M-A-T-H. That is in a set notation, M, A, T, H. Determine the number of 3-letter codes that can be made from the letters in this word. Express your answer as a permutation, a product, and an integer. So, remember, permutation, what's my possible outcome? There are 4 letters, M-A-T-H, and then I want to find the 3-letter code. So remember what we said again. This is the same thing as starting at 4, and I'm going 3 spaces down. So 4 times 3 times 2, and all of this will give me 24. Consider only the letter M-A-T. How many ways can these 3 letters be arranged? Express your answer in factorial form and as an integer. So there are 3 ways, M-A-T. And remember, this is when we use the factorial. How many choices? There are 3 letters, meaning 3 factorials. So this will be 3 times 2 times 1, which is 6. Write out all the codes for these M-A-T and verify that we should have 6 choices. So we should have M-A-T, my first choice, M-T-A, A-T-M, A-M-T, T-A-M, and T-M. Kind of started with the M's, then I did A's, then I did the T's. Now it says, using your answer to part A and B, calculate the number of 3-letter subsets. So think of this. Each 3-letter subset has correct 6 times as a permutation. So now what we can do is that this can be 24 over 6, which is the same thing as 4, which brings us to, before we do anything, to our formula. But it says, what can you calculate from exercise 1D was the number of combination of 4 letters, taking 3 at a time. The key difference between a combination and a permutation, and this I would want to highlight, the key difference between a combination and a permutation is that permutation, the ordering of elements matters, and combination is when the order does not matter. And this is when you decide, do I use a combination, do I use a permutation? So if the order matters, then that's a permutation. If the order does not matter, that's a combination. So from that I can get my formula for combination to be C and R is equal to this, or we can write it like we did the last time, n factorial over r factorial n minus r factorial. Now what the heck does that formula mean? This again, you can do this on your calculator, just in my previous example. So it says, Janine would like to select DVDs to bring with her on a long plane flight. She has a collection of 22 DVDs to choose from. Calculate the number of unique DVDs that she would like to choose from. So the order that she chose the DVD matter. So then we would have to calculate the probability. So first I want to find the probability. There are 22 DVDs and she wants to choose 3. So this becomes 22 times 21 times 20, which gives me 9,240 ways. And then I want to find, because she can choose the DVD, it doesn't matter what the set is. So it says, but because the order she chooses the DVD doesn't matter, the number of sets would be 3 factorial, which is 3 times 2 times 1. So this works out to be 9, therefore 9240 over 6, which is right from here, would give me 1,540 choices. So again, this goes back to the formula of P22 over 3 factorial. And this would give us the number of unique ways. So you have to remember, if the order that she chooses the DVD matters, then there are 9,240 ways. But in this case, since the order does not matter, we just choose we take our subset, which is a 9,240, and we divide it by 3 factorial. Where is this 3 coming from? This 3 is actually telling you here because she's choosing 3 DVDs. Okay, let's sink that in before we move on to question 3. Again, I want you to make sure you pause the video, process this, and then we'll see this. Now, Mr. Wheeler's math team must choose 4 of his competitors to compete in a group question. If the team has 12 members, how many different 4-member groups could they form? So the first thing we're going to see, if the order that Mr. Wheeler chooses the competitors matter, then what would we do? So the order would be, and I want to do my formula, probability of 12, and I'm choosing 4 over, because the order does not matter, 4 factorial. So this becomes 12 times 11 times 10 times 9. 4 factorial is 4 times 3 times 2 times 1. Now again, why did I do? Because we simply want to count the groups. We don't care about anything else. We just want to count this. That's why I ended up doing this. So this top works out to be 11,880 over 24, which gives me 495 groups. Now I want you to go ahead and practice using this on the calculator. Again, we go to the same thing, menu, probability, and now I'm going to choose combination. Okay, so when you do this on the calculator, simple, you should get 210. Here I'm getting 1. Here you should get 36. And then here is a little bit more complicated. So to get a fraction, you go to CTRL division, and then you should get the top part to be 20 over 120, which is the same thing as 1/6. This actually, first, before we get that, we will get 6 times 6. If you're not sure on how to enter that, come and see me, please. You need to know how to do this on the calculator. Last example, a bag contained 12 marbles, which includes 7 red, 5 blue. Roja reaches into the bag and pulls out 4 marbles. A. How many different sets of 4 marbles can be pulled out from this bag? By different, we literally mean different marble regardless of color. So, there are, does the order matter in what she pulled this out? No, because she can pull however she wants. So we know order doesn't matter. It's a combination. There are a total of 12 marbles and they want sets of 4. So C, 12C4 is actually going to give me 495. And you can do this on the calculator to get this, which is perfectly fine. How many different sets containing 2 red and 2 blue? So now we have to do this in increments. 2 red. So How many red marble? There's 7 red, and I want to choose 2 red. Remember, the order doesn't matter. This will give me 21. Then I want to choose 2 blue. How many blues? There are 5 blues, and I want to choose 2. So 5 choose 2 is 10. It says, how many sets? So again, it says set of 2 red marbles, and in this case, we need to make a note. When you see the word AND, this means multiplication. So 2 red is 21, and means times 2 blue, which is 10. So the total ways would be 210. Okay, so keynote, let's just write it here. And means multiplication, and if you see the word or, that means addition. And this is 2 keynote that you need to remember as well. How many sets contain all red marbles? So remember, they're sets of 4. Okay, remember we said that we're all doing a bag with a set of 4. So since it's a set of 4, you know how many reds. There's 7 red, and 4 has to be 4. We want to pull 4 red. So 7 choose 4 is 35. And then our last part for today says how many sets contain all reds or all blue. So let's say this was all red. We just calculated that over there. 7 choose 4, which is 35. Now, if it's all blue, there were 5 blue, and we need sets of 4. So 5 choose 4 is 5. And it says all red, which is 35. Or, remember the or we set up here. Or means addition. So, or all blue. In this case, when I add this, it would be 40. Alrighty, I know that was a lot. So remember, whenever you see the word and, it means multiply. Or means addition. And going back to our first page, when the order matters, that's a permutation. If the order and where I'm picking out these objects does not matter, then that's a combination. Okay? Alright guys, you know what to do. Go practice, practice, practice. Practice makes perfect. Good luck!